Right, so this video is recording. Let me just double check, triple check. It's recording, cool, right. So what I'd asked the class to do is these reacting mass calculations. So in these reacting mass calculations, you will be given a mass of something. And what you will have to do is you will have to turn it into a value for moles. So we have to be able to integrate mass and moles. And we do that by using the mass Mr. Moles triangle. If you take the mass of a substance in grams and you divide it by the MR, you will work out the moles. All right. So I'm afraid this is going to be teaching by examples. I'm going to give you worked examples. So what I'd expect you to do, we're going to do questions 1 to 9 from here. First thing I would like you to do is to write down the equation nice and big. 2 Al2O3s will make 4 Als plus 3 O2s. What this means is that 2 moles of aluminium oxide will make 4 moles of aluminium and 3 moles of oxygen. A mole is just a number. So 2 dozen would make 4 dozen of these and 3 dozen of these. It doesn't matter about whether you understand the concept of the mole necessarily. 200 would make 400 of these and 300 of these. Okay. Aluminium is extracted from aluminium oxide as shown. Calculate the mass of aluminium that can be formed. So the first thing you do, it's asking us to calculate the mass of this. So I would like you to draw a box. That's your target box. The mass of aluminium that can be formed when 1020 grams of aluminium oxide is reacted. So I've got this grams of aluminium oxide. So you write that underneath here. You've got 1020 grams. So it's asking you, if I give you 1020 grams, how many grams of this will you form? Now, there is no direct way of doing this. What you've got to do is you've got to turn this grams into moles. Then we can look at the equation, and the equation gives us something called a mole ratio, and then we can come back up. Anyway, what you're going to do is you're going to draw an arrow going down, then you're going to draw an arrow going across, and then you're going to draw an arrow going up. This central arrow is called the ratio arrow, and it tells me that 2 moles of this make 4 moles of this. So I would like you to take that ratio and put it onto this line. 2 moles of this makes 4 moles of this. So that ratio arrow, this comes from there and that comes from there. You probably are aware that that is the same as a 1 to 2 ratio. So you write the simplest version of that ratio there. Okay. What you're then going to do, you've got mass. We are trying to work out the moles of this and then the moles of this. So the first thing you do, when you go down, this is where you're going from grams to moles. So you're trying to work out moles, so you're going to divide by the MR. So when you go down, you divide. We're going to divide by the MR. Okay, so you're going to divide by the MR of Al2O3. Listen carefully to this, please. You ignore the big number. You ignore the big number. The MR of Al2O3, I'm going to work that out. Aluminium, 27, and there are 2 of them, and oxygen is 16, and there are 3 of them. I did this before during the lesson when it was meant to record. The aluminium oxide is 27 plus 27 plus 16 plus 16 plus 16. So you're going to divide by 102. That's the MR. Okay, so I'll do that now. 1020 divided by 102, which is the MR, is 10. So you've got 10 moles of aluminium oxide, and you've just got yourself 1 mark, 2 marks in the exam. You now know that from the equation, 2 moles of this makes 4 moles of this. So 1 mole makes 2 moles. In other words, 10 moles would make 20 moles. You've just got yourself another mark in the exam. Tick, tick, tick. So 3 marks so far. You've used the ratio arrow. When we went down, we divided. When we go up, we multiply by the MR. Have a look up here. If you've got moles and you times by the MR, it will give you a mass back out. So now I've got this value 10 on my calculator. I'm going to times by 2. Now I'm here with 20. Now I'm going to times by the MR of aluminium. And listen again, you ignore the big number. So I go to my periodic table. The number is 27. So times by MR times by 27. So you're going to do 20 times 27. And this gives you a value of 540 grams. Job done. So we go down, across, and up. Notice the symmetry here. Down, divide by MR, up times by MR, and this is your ratio arrow. Okay, so I'm sorry, you can pause it there, have a little go at that, but I'm going on to the next one. Two CAs, write down the equation, we reacted one of those to make two CaOs. Two of these reacted one of these to make two of these. Okay, 2 moles of this reacted 1 mole of this. Calculate the mass of oxygen, so that's where my box goes, needed to react 10 grams of calcium. They're giving me 10 grams of calcium. They're not giving me anything of this. I'm not bothered about it. Okay, so as my grams, from there I go down, across, and up. On this across arrow, it's the ratio. So 2 of these react with 1 of these. There's a 2-to-1 ratio, so you put that on there first. Down, you divide by the MR, up, you times by the MR. So I'm just preparing everything before I touch my calculator. This will give me a moles, and this will give me a moles. So all I need to do now is fill in the gaps. Okay, 10 divided by the MR of calcium. The MR of calcium, 40. So I'm going to do divide by 40. And then when I get to this side, I'm going to times by the MR of O2. And that is 16 plus 16. That's going to be timesing by 32. Have a look there. O is 16, so O2 will be 16 plus 16. That's ready for me to go now. I can now plug this into my calculator. So I'm going to go. I'm just going to follow these steps. I have 10 grams of calcium. I divide by the MR, so I divide by 40. 0.25. You just got 1 mark, 2 marks in the exam. 2-to-1 ratio. So if I had 2, I would have 1. In other words, we're going to divide this number by 2. So we go divided by 2. 0.125. 0.125. You just got yourself another mark. Now you're going to times by 32. Times by 32. 4 grams. Done. 5 marks. Celebrate good times. Come on. Right, next. C3H8 plus 5O2 makes 3CO2 plus 4H2O. Then you go, what have you given me? What mass of propane? This is propane. What mass of propane? There you go. So how much of that can burn in 48 grams of oxygen? So they're giving me 48 grams of oxygen. So this is showing you that you can go in the other direction too. When you've got the mass, you go down from the mass, then you go across, and you come up to the box. When you go down, you divide by the MR. When you go up, you times by the MR. And this arrow across the bottom is the ratio arrow. There are 5 oxygens to every one of these. So 5-to-1. I'm almost ready to go, but I'm going to work out my MRs first to make it easier. The MR of O2. Listen carefully. Not 5O2. You ignore the big numbers. Divided by 32. So I'm going to do divide by 32 there. This will give me the moles of that. Then the ratio will give me the moles of this. And then I'm going to times by MR. The MR of C3H8. So that is, carbon is 12. 12 plus 12 plus 12. That's 36. And then 8 hydrogens. That's 8 times 1, 36. 44. And times by 44. I worked out the MR of C3H8. Okay, I think I'm ready to go. I've got a number here, a number there. I've got a ratio. I should be fine. So I go 48 divided by 32 equals 1.5 moles. 1 marker there, 1 marker there. A 5-to-1 ratio, which means that if you had 5 of these, there would be 1 of these. In other words, we're going to divide by 5. So look at my calculator. I haven't pressed clear. Divide by 5. 0.3. You will need 1.3 moles of this. And then you times by 44, times by 44, 13.2. Is it 44? 12, 24, 36, plus 8, 44. Yeah, 13.2 grams. 1 mark of the ratio, 1 mark times by 44, done. 5 marks, 1 mark of that as well. 5 marks. They often ask you in the exam, do it to 1 decimal place, 3 significant figures, or whatever. They are the 3 examples I went through in the class when I should have recorded it first time. The rest of the questions to go up to question 9, and try question 10 if you want, but it's really hard. It's an A-level question. It's a bit weird. It's not questions, but give it a go. What mass of ammonia can be made from 20 grams of hydrogen? Something just beeped on my computer. Please don't let it be somebody telling me I've made a mistake. Nope. Okay. So this question looks fine. What mass of ammonia, that's that, can be made from 20 grams of hydrogen? So you're given 20 grams of that, down, across, and up. What mass of sodium hydroxide? That's sodium hydroxide. There's your box. Is needed to neutralize. 24. Okay, watch out. Kilograms. It's got to be in grams. So you've got to do a conversion there. Next. That one's fine. Another kilograms there to watch out for. That one's fine. That one's fine. The answers are here, but they're not laid out like I've laid them out. But this one refers to the down, which is why it's a divide. There's the MR. This is the across, so that's the ratio. And this is the up. So down, ratio, up, if you wanted to go through your answers. I hope that's all right. So that's specifically for those people who missed the lesson or couldn't access it. I'm going to try and stop recording this now, and hopefully it will save.